Hello everyone. In this video, we are going to solve this exercise on hierarchical clustering. Suppose you are given a distance matrix. Here is a distance matrix. So 5 by 5. This means we have 5 observations. Then we got the 5 by 5 distance matrix. Now perform the hierarchical clustering. So let's use the single linkage in this exercise. So what does it mean by single linkage? It's going to be in the next page of this exercise. But before we do that, we know this is a distance matrix and it's a symmetric. And this is our capital D, right? So this is 1, 2, 3. We have 5 observations. And then we calculate, or you can call it 5 sample observations. We calculate the observation and the distance matrix. Itself, the diagonal is 0. Now, single linkage. Let's look at the algorithms first. So basic algorithms, we compute the proximity or similarity matrix like the one that we were given. We are already given the proximity matrix. If you were not given the proximity matrix, for example, if you were given the original data, like in the exercise of distance computation, we have different kind of observations, and each observation has different predictors. Now, in this way, we need to do the proximity calculation, the matrix calculation. Now, let each data point, that means each observation to be a cluster. Then we're going to find out the closest one. Then each one of them is a separate cluster. Then we are going to do the hierarchical clustering. We call it agglomerative clustering, the bottom up. So merge the two closest, then update, then until only one cluster remains. So this is the algorithm. If we put it in the flowchart, that is, we start the algorithms and we list the original data, all the observations with their features or with the predictors. Then we compute the distance matrix using those data values. We set each object of each observation as a cluster. And then number of clusters, whether it equals to 1, it does not equal to 1. For example, we have 5 observations. We have 5 clusters. So if it's no, then we merge two closest ones. Then we update the distance matrix. Then we check whether we have all the observations in one single cluster or not. If no, then we continue to do it. We do this in a iterative way until there is only one cluster left. Then we end the algorithms. And we talked about the single linkage. So single linkage is the distance between one cluster and another cluster is equals to the shortest distance from any member of a cluster to any member of the other cluster. For example, here we have 2 clusters. Single linkage means the shortest one. So you see the distance from 1 to 3, 4, 5, 2 to 3, 4, 5. And then you see 2 and 4 is the shortest one. So shortest one from any member of a cluster to any member of the other cluster. That means this is the shortest one. So cluster distance, the cluster distance is actually represented by the shortest distance from any member of one cluster to any member of the other cluster. So this one, if we use single linkage, this will be D24. And a complete linkage is the distance between one cluster and the other cluster is equal to the greatest distance from any member to any member of the other cluster. That means you see here 1 and 5 is the greatest distance among all elements, all observations in these 2 clusters. So this is D15. Average linkage. Average linkage is the distance between one cluster and another cluster is equal to this is the average distance from any member to that means you calculate all the distance, D13, 14, 15, 23, 24, 25, and then divide by how many linkage you have, 6, right? How many link you have, lines, we have 6 lines. So this is the average. if we want to highlight, let me delete this part. This is the average distance among two clusters. This is the greatest distance, okay? And this is the shortest distance. So single linkage is the shortest one. Now, based on this definition, let's do the hierarchical clustering for this distance matrix. I have already solved this beforehand and put it in the slide. And now let's have a look at this slide. Let's go to the next page. So again, this is a single linkage, the shortest from any member to any member of the other cluster. And this is the largest distance among between these two clusters, the member of these two clusters. And this is average. So you see here, D13, 14, 15, 23, 24, 25. You add all of them together and divide by how many link you have. That's average, 6. Now, again, single linkage. If you have two clusters, this is one cluster, this is another cluster, you take the minimum one. So now let's do this exercise, right? This exercise, we have used the single linkage. So this exercise, we use a single linkage, 9, 3, 6, 11, 9, 6, 3, 6, 11. So here is the distance matrix of 5 observations. Treat each observation as a single cluster. We started the clustering by merging the two closest observations. So which two observations are closest? We find all these numbers, which two are closest? Obviously, this 2 is the smallest. So if this 2 is smallest, that means 3 and 5 are very close to each other. We merge 3 and 5. Okay, the minimum is 5 and 3, 2. Then 5 and 3 are merged to form the new cluster 3 and 5. Now, if we merge them into one cluster, we need to update the proximity matrix. Now, we don't have, this one is original matrix. Now we put 3 and 5 together. This is one cluster. If we calculate the distance between 3, 5 to 1, 3, 5, what are the remaining observation? So 3, 5, remaining is 1 to 4. Then we need to calculate between the cluster 3, 5 to 1, 3, 5 to 2, 3, 5 to 4. And because this is single linkage, we need to calculate which is the minimal distance from any member in one cluster to any member of the other cluster. So here 3, 5 is one cluster, 1 is another cluster. So this is 3, 1, 5, 1. We take the minimum. This is 1. 3, 1, 3, 1 is 3, 1 is 3. So 3. 5, 1, 5, 1 is 11. So this minimal distance is 3. So we put a 3. 3, 5, the cluster 3, 5 has a distance 3 from cluster 1. Okay. So the distance from the cluster 3, 5 to cluster 1 is 3. And 3, 5, 2. So 3, 2, 5, 2. So 3 to 7, 5 to 10, 7, 10. Which one? It's 7. 3, 4, and 5, 4. 3, 4, 9, and 5, 4. 5, 4 is 8. So 9, 8 is 8. So this will be 3, 7, 8. And then we continue to put the distance of others. For example, 2 to 1. 2 to 1 is already here, right? 2 to 1, 9. 4 to 1. 4 to 1 is 6, 5, right? 4 to 1, 4 to 2. 4 to 1, 4 to 2, 6, and 5. So we put it here. Now we updated the proxy matrix. Those numbers we have already known before from this matrix. So we only need to calculate the new cluster 3, 5 and the distance to all other remaining observations. So this will be the new proxy matrix. Now from this proxy matrix, the smallest distance between pairs of cluster now is 3. This one 3, right? Is a minimal. So 3 and 3, 5 and 1 should be merged again. So we merge cluster 1 with cluster 3, 5 to get a new cluster 1, 3, 5. Okay. So find the distance between cluster 135 and the remaining observation 2 and 4. Now, the 135 to 2, 135 to 4, this is like the element is like 35 to 2 and 1 to 2, right? So 35 to 2 is 7. And then 1 to 2, 1 to 2 is 9. 35 to 4 is 8. 1 to 4 is 6. So this one is 6 and 7. Now we update to the new cluster, the new proxy matrix. Now which one is the smallest? 2 and 4 now is the smallest. Now we should merge 2 and 4. And the smallest distance now is 2 and 4. We merge cluster 2 and 4 to get 2, 4. So 2, 4 cluster. Now we need to have 1, 3 and 2, 4. What is the distance? Distance is actually minimal 7, 6. So it's 6. Okay. Now we put all of them together. So this is a dendrogram. So first we merge 3 and 5, and then we merge with 1, and then we have 2 and 4 in one cluster. Then we merge everything into a single cluster. So this is step 1. We merge 1. Step 2, and then step 3, and then we have no update. Then we finish the hierarchical clustering. So this is an example to use the single linkage. But if you are interested using other linkage, for example, complete linkage. Complete linkage is the maximal distance from any member of one cluster to any member of the other cluster. Okay, then we use that to be the distance between two clusters. And same, I put the answer here, and you can check it out. So still, we have 5 observations. Now, treat each observation as a cluster. We start clustering by merging the 2 closest ones. So the first step is still the same, 3 and 5. We merge them together because they have the smallest distance. Smallest distance. Now they are merged. And then we find the distance. Now this is not minimal, this is maximal now between cluster 3, 5 and the remaining. So here, this is a difference, okay, max. So if we take the max, then this column will be different. Now, instead of the previous 3, now we take 11. So it's 11, 10, 9. So if we do this kind of complete linkage, we can see that the next step, what is the smallest distance? This is 5. So instead of the previous one, we merge 1 and 3, 5 in this step. But now we are going to merge 2 and 4. So now the smallest distance is actually 2 and 4. So we merge 2, 4. Now you got a 2, 4 cluster. Then you continue. So you have 3, 5, 2, 4, and then 1, 2, 4, and then you got a 3, 5. So average linkage. Average linkage is you calculate the distance from any member in one cluster to any member of the other cluster, then divide by the number of links you have. This refers to n refers to the number of observation in one cluster. In this case, it's a cluster UV and a cluster V. So you just multiply the members in one cluster and the other cluster. Then here is the total number of links you have, distance calculation you have. So same, you have this one, then you can do the, when you do the D351, you actually do the average. So this is 7. So when you see here, still the difference is you can either take the mean or max, or now the complete linkage is average. You average these two distance. This is 7, 8, 5, 8, 5. Now 5 is the smallest. Now we have 3, 5, 2, 4, and 1. And then we continue to calculate the average distance between two clusters. And then we can continue to do that. Now you got 3, 5, 1, 2, 4, and then 1, 1, 3, 5, and then you merge them together. So this is hierarchical algorithms. I think the key is here. Single linkage is the minimal. So when we do the calculation here, this is a minimal. but a complete linkage is actually the max, and then average linkage is you do the average. So minimal, maximal, and then average linkage. And the algorithm is like this. So compute the proxy matrix that each data point to be a cluster, merge to closest cluster. Now the key here is to update the proxy matrix. Now you have already formed the clusters. How to calculate a cluster and the cluster, the distance between two clusters. You can use 3 different ways to do it. This is a single linkage, complete linkage, and the average linkage. Okay, so only the key part is how to update. So if you use single linkage, then this is a single linkage algorithm. Complete linkage is a complete linkage algorithm. The only difference is here, how to update the proxy matrix until there is only one cluster remains. Okay, so now we finished this exercise on hierarchical clustering. Hopefully this exercise give you a better idea on how to do the hierarchical clustering. It's a very straightforward example. I will post this solution also online together with this exercise. Okay, everyone, now we complete the clustering part, hierarchical clustering exercise. See you in the next lecture.